All right, Kaylee Chase. So for those labs that we missed, okay. So the first one's separating mixture lab, and then the physical versus chemical changes lab. Just gonna kind of walk you through. So we'll start with the separating mixtures lab. So if you look at this one, it's got these slides on here. So that's where we're gonna find all the questions, things like that we need to do in our notes. So first thing that we did basically is wanted to look at we were looking at the difference between element compound mixture, and how can we separate these mixtures. So what we had is we had this mixture that had little tiny lead bb's in there. We had iron filings, salt, and then coriander. Apparently coriander is actually a real thing. I just found that out, but it looks like a little tiny, like round little seed. And so we had these all mixed together. Okay, so the goal of this lab was to figure out, okay, how could we separate that using this stuff? Okay, and so that's kind of what I want you to do here. Is you don't have to use all of these, but kind of like think about how would I go about separating these. Now, this is going to be challenging because you can't see the stuff. It's easier when you can hold the materials, look at the materials, see what they are. Um, but how would you go about trying to get the lead, iron, salt, and coriander separated from each other using only these things here? And you can use water. So that's what this is here with the procedure. So basically, just write the steps. How would you do it? Okay, so you could say, for example, one of the big ones was we know certain things are magnetic. So they said, well, we're going to use the magnet to do this. Okay, so anyway, go ahead, pause the video, think about how you'd separate this. Okay, and then we'll talk about the other stuff. Now, um, hopefully you've written down your procedures. So looking at this, what a lot of people did is they automatically said, oh, okay, yeah, the magnet. They stuck the magnet right in there. The iron filings stuck right to it. It was perfect, except for then they pulled out the magnet, and then all the iron filings were stuck to it. So one of the creative things we saw was they wrapped the magnet in aluminum foil before they put it in there, which is kind of cool. Then they took the magnet out, all the iron filings dropped off the aluminum. That was cool. They also used the aluminum foil as kind of like a strainer or a colander. So they made little tiny holes so all the salt would go through, and the lead BBs and the coriander wouldn't. And then after that, coriander is much bigger than the lead BB, so it's easy to just kind of like scrape off. So those are just examples of some effective ways to get those things separated. So with the analysis portion on this, obviously you can't do this, so you can't explain how well the steps worked. So the analysis portion just write absent on there, um, because you weren't able to actually test how well this was working. So, but the synthesis, we do want to look at this. So it says compare and contrast the terms mixture, element, and pure substance. Okay. Um, or and compound, and give an example of each from this lab. So when it says compare and contrast, it just kind of means like break them down. So element is a pure substance, or elements come together to make compounds. If we just have one thing, whether it's one type of element or just a single compound like H2O, that's what we would call a pure substance. Okay, so a pure substance can be just an element or just a mixture, or sorry, or a compound. Then those things can come together and create a mixture. Now, the key with the mixture is they're not chemically bonded together. Um, Elements and compounds will be, okay. Uh, and so that's what we're looking at. So an example, the whole thing, the salt, the iron filings, lead, and coriander would be an example of a mixture. Okay, lead and iron are examples of elements and pure substances. And salt is a compound, and if we had just salt, that would also be a pure substance, right? If we just had NaCl. Okay. So we can take a second and write that down if you need. Now, the next one, it says for each of the four components, what specific property enabled you to separate it from the mixture, right? So, like, for example, iron. Iron is magnetic, right? So the property is magnetism. Okay, so iron was able to separate because it was magnetic. For the lead, the size of it, right? So if we built the colander, the size of each component is really what we use to separate everything after that. The coriander being the largest, the lead being bigger than the sand, or the salt, so it could fall through the tiny holes. That's what we mean there. Now, finally, this third question is kind of the most important. So it says, could you separate any of the four substances from the mixture any further by physical means? Meaning, could you take that lead and break it into smaller individual components that aren't just small pieces of lead? Could you do that with iron? Could you do that with salt? And the answer should be no, right? Because what we ended up there when we separated them from the mixture was a pure substance, whether that was pure NaCl or pure lead, pure iron. That's the only substance that we have. From there, that means we would have to use chemical means to break it down any further. Okay, so that's the separating mixtures lab. So we can just write that one down. Now, so for the other lab, the physical versus chemical changes, you can just draw this in your notes. Uh, we kind of just went, what we did is we just went around the room and we had 6 different stations, each with a different reaction or not reaction taking place. And we had to identify, was this a physical change or a chemical change? Okay. So the first station was just a cut apple. So they just saw an apple that was cut in half, but they did notice browning on the surface. So what a lot of people did is they said this was an example of a physical change and chemical, because the apple being cut in half, it's still an apple. But the browning that's taking place on the surface is that that apple's actually being oxidized. So oxygen is binding or chemically bonding with some of the structures in the apple, causing it to brown. Okay. Food coloring in water. This one's a little tricky actually, because how do we know if the food coloring is actually bonding to the water or not? But it's not. So it's mixing through and it becomes nice and uniform, but eventually that color would settle out of the water as well. So that's just a physical change. We didn't change the chemical components of either of those things. Yeast, though, yeast and sugar. Yeast is a little actually living organism that consumes sugars and creates carbon dioxide. So what they saw was that this little test tube started bubbling, foaming, and what they were seeing is actually that production of carbon dioxide as yeast consumed the sugars within that water. So that's a definite chemical change. We're changing the chemical components of each of those each of those components. Same thing with vinegar and milk. If you've ever done that, it's pretty gross, right? As soon as you put it in, the milk curdles and solidifies and gets all nasty. That's because it is actually chemically changing the structure of the milk, and it's bonding to components of the vinegar. Okay. Play-Doh, just had 2 different colors of Play-Doh, mixed them together. That one's a pretty easy physical change. We can even see the individual components still. And then finally, again, folding a paper airplane, definitely a physical change. So the big thing that we want to make sure we add to our table here is physical changes. They don't change the chemical properties, meaning if I fold a piece of paper, I still have paper. It's still all the same. It might have changed its size or shape, but it's still paper. So anything like crushing, oh, that says crashing. That should say crushing. Crushing, folding, bending, breaking, grinding. Those are all going to be examples of just a physical change. We're just changing the physical components of that. Same goes with like melting and freezing, right? So if we have ice and we melt it, it's just now water. So instead of frozen water, we have liquid water. If we boil it, it just becomes gaseous water, right? So it's still water in all 3 phases. So a phase change is always a physical change also. Now, when we go to chemical changes, things we see is like bubbling, right? Because now we're producing a gas, okay? Bubbling, fire or heat, if we light things on fire, burning paper, or an explosion, that's going to be signs of a chemical change. Okay, we're changing the chemical components or the bonds of that thing. So explain how physical changes are different from chemical changes. So you should be able to do that. And then synthesis. How does an atomic bond form? So we should be pretty good on this. How do valence electrons pertain to this? So what is the goal? Why do atoms bond in the first place? Why do we get these chemical changes? Okay. So let me know if you have any other questions. Just add those to your notes, take a picture, and submit them on Google Classroom. Thanks.